Alright, so in this video we cover section 4.5, which is inequalities involving quadratic equations. Not equations, quadratic functions. So how are these going to look like as opposed to the typical equations? Well, so look at the inequality signs. In this case, we're not going to have the equal 0, and then use whatever method that we know. In fact, they will come in handy because at one point we will have to turn this into equation to find our critical values, and then we're going to use another criteria in order to give answers to these inequalities. So, well, from the geometric point of view, what does it mean to solve an inequality? So here I have the graph of y equals x squared minus 3x minus 4, which has these two x-intercepts. They are -1 and +4. All right, so for which values of x is y greater than 0, and for which values of x is y less than 0. So when we solve a quadratic inequality, so we are looking for the interval in which I'm going to use, so in this case, in which the parabola is negative, that is, the y values are below the x-axis. And to answer the first part, we'll look at the intervals in which the parabola is positive. Okay? So notice the x-intercepts are x equals -1 and x equals 4. So in this case, for what values of x is y greater than 0? So using intervals, I'm going to describe this green part using interval, which is -infinity to -1. Exclude it because it's only greater than. We're going to look at an example to show how it looks like when we have the greater than or equal and then the union sign or union symbol, and then it goes negative and then it goes positive again, starting at 4 and going all the way to positive infinity. Now, for what values of x is y less than 0? That is, what is the interval in which the parabola is negative, and that goes from -1 to 4. So that's from the graphical or the geometric point of view. Now, how do we do this in the algebraic form? Is there a form to do it? Yes. So solving quadratic inequalities algebraically, well, the first thing we do is to replace the inequality sign with an equal sign to turn the inequality into an equation. Okay, so let's look at an example and check in with every single step that we have here. So I'm going to write x squared plus 6x minus 5 and turn the inequality sign into an equal sign. Solve the corresponding quadratic equation to find the critical number. So in this case, the nice thing about this equation is easily solved by factoring. So in this case, factors of -5 that add up to 6. It's going to be, I would like to say, hold on, did I do a little typo here? Let me check. I'm afraid I did a little typo. So I believe this should be a plus. Otherwise, it's not going to work. So there's a little typo here. Change it to a plus. And so this will be x plus 5 and plus 1. 5 times 1 is 5. 5 plus 1 is 6. Right? Otherwise, it was not going to work. Okay? So how are we going to deal with this? Well, so these numbers, x plus 5 equals 0 and x plus 1 equals 0. That means x equals -1 and x equals -5. So that's going to lead to the third step. Draw a number line and plot the critical points. Use open circles if the inequality is less than or greater than, which excludes the critical values, and closed circles or full bubbles if the inequality sign is either less than or equal or greater than or equal. In those cases, we include critical values. So this will be giving rise to intervals to test. So I'm going to draw two open circles here. One open circle, another open circle. And then I'm gonna write my critical numbers from smaller to larger. That is the -5, -1. And I'm gonna draw a number line. Alright. Right next to the chart of signs to determine the solutions is what I'm gonna do here. I'm gonna go back and write down the old factors, the factor x minus 5 and x plus 1. So I'm going to use this chart to determine the solution. So when I plot the critical numbers on the number line, I'm going to get 1, 2, 3 intervals to test. And I'm going to choose a test value in every single one of the intervals. For example, over here, I'm going to choose x equals -6. Here I'm going to choose between -5 and -1. I'm going to choose x equals -2, and between -1 and on, I'm just going to use the easiest, x equals to 0. And then I'm going to plug in these numbers in pink over here in the quantities in purple. Now at the end, I'm not going to care at all about the signs of, the numbers that I obtain. I will only care about the signs. So for example, -6 minus 5, that's going to give me -11. I will only care about the sign. And then -6 plus 1, that's also negative, and that's going to be -5. Then what am I going to get here? Well, actually, this was supposed to be positive, not negative. Never mind. But it's still going to be negative. So -6 plus 5 is -1. -6 plus 1 is -5. All right, I'm going to go with the middle one. I'm going to plug in -2 plus 5. That's going to be +3. And then -2 plus 1 is going to be -1. And finally, over here, I'm going to plug in 0 plus 5, which is 5, +5, and 0 plus 1, which is positive. Now, notice I have 3 columns here. I'm going to multiply the signs of the columns. So for example, here I'm going to have positive, negative times a negative is going to be positive. Positive times a negative, that's going to be negative. And positive times a positive is positive. Now, I'm going to go back to the original question. They're asking us to find the intervals in which the quadratic function is greater than 0. Greater than 0 is the same as saying positive. So it's going to be over here in this interval right here and over there. So I'm going to shade the intervals in which this is true, in which this is greater than 0. Greater than 0 is positive, greater than 0 is positive. Now, I have the shade, I have the graph, if you will. Now we need to write this using interval notation. So solution set, this will be -infinity to -5, and union -1 to +infinity. Now, let's look at another example. Okay, so let's see, what do I have? We have 2x squared less than or equal x minus x plus 10. So first of all, we need to have all terms on the left hand side of the inequality. To do that, I subtract x and subtract 10 on both sides. Okay, so I'm gonna get 2x squared minus x minus 10 less than or equal to 0. Now, in order to solve this inequality, I need to first turn it into an equation and then use a suitable method to solve this equation. I'm going to use the diamond method. 2 times negative 10, that's negative 20, and bring down the middle coefficient. So in this case, factors of negative 20 that add up to negative 1, negative 5, and 4. So I'm gonna split this into negative 5x and plus 4x, and that's minus 10 and 2x squared at the beginning. So I'm gonna solve this by completing the square. So the GCF from the first group will be x only, that's 2x minus 5. And the GCF on the second group, I'm going to factor a 2. And I'm going to get 2x minus 5 as well. That means we're going to get the following 2x minus 5 equal times rather x plus 2 equals to 0, which means x equals 5 halves. Over here, x equals negative 2. Alright, let me go back to the method or the steps to solve this type of inequalities. So now I'm going to draw a number line, but in this case look at the inequality symbol. It has the less than or equal, so in this case I'm going to include closed circles or full bubbles. Okay, so I'm going to have 2 full circles, one for the smallest of them of the critical numbers and one for the largest of the critical numbers. And I'm going to do the same. I'm going to have the factors 2x plus 2x minus 5 and x plus 2. And on each interval, I'm going to choose a test value, a number below negative 2. I'm going to say x equals negative 3, a number between negative 2 and 5 halves. I'm going to say x equals 0, and a number larger than 5 halves. Well, 5 halves is 2.5. A number that is larger than that is x equals to 3. So I'm going to go ahead and multiply this. So 2 times negative 3 is going to give me negative 6 here, but negative 6 minus 5 is going to give me a negative number. Then I'm going to plug in negative 3 plus 2, which is negative 1. That's a negative sign. I'm going to do the same here, but now with x equals 0. Plug in 2 times 0. That's a 0 minus 5. That's a negative 5. And 0 plus 2 is positive 2. Finally, with the number x equals 3, plug in 2 times 3, which is 6 minus 5. That's positive 1. And over here, 3 plus 2, that's a 5, positive 5. Okay, so in this case, what are we going to get? Let's multiply each column of signs. Negative times a negative is positive. Negative times a positive is negative. And positive times a positive is positive. Now, let's go back to our original question. In this case, less than or equal 0, in this case, means negative. So I'm going to shade this interval right here, and I'm going to express that using interval notation. It's going to go from negative 2 to 5 halves. But in this case, as opposed to the previous example, we had open bubbles. We used parentheses. In this case, we have full bubbles. We're going to use brackets. So this is final answer. And this also wraps up this section. I'll see you on the next video.